Welcome to VideoTutorial.net's SolidWorks 2010 Sheet Metal course. In this first lesson, we're going to be learning about the base flange. But first of all, what is sheet metal? You can think of sheet metal as a thin solid with a constant thickness value. The sheet metal toolset is available as a tab. Right-click on any of the tabs and select it from the drop-down list. You can also access the sheet metal toolset via the insert command, sheet metal. Here we have a number of tools. Base flange is the only one active currently. The base flange is a sketch-based feature, so we'll need to create a sketch first. Let me right-click on the front plane and insert a sketch. Now I'll activate the line tool. Place my line, second line, and a third line. And let's dimension. 50 millimeters, accept. 45 here, accept. And 60 here. Accept. And an angular dimension, 135 degrees. OK. And 120 here. OK. Let's exit the sketch and go to the Sheet Metal tab. Activate the Base Flange tool. Some options here are similar to the extrude options, such as Direction 1 and Direction 2. Let's use a depth of 20 millimeters. I'll use the arrows to make my adjustment. Next, we've got the sheet metal parameter section. Here we can specify the thickness of our sheet metal as well as the bend radius. We also have the option to create the solid inside or outside the sketch by checking or unchecking the reverse direction checkbox. The next section covers bend allowance. Here we can control bend allowance in one of four ways, using a bend table, the K-factor, bend allowance, or bend deduction. We're going to be looking at all of these options in more detail in subsequent lessons. For now, I'm going to use the K-factor method with a value of 0.5. We'll also be exploring the use of the K-factor in greater detail in subsequent lessons in this course. Let's take a look at the next section, auto relief. This used to be known as bend relief. This is basically a small cut in the body of the sheet metal that allows it to bend correctly. We're able to use one of three different auto relief methods. The first one is rectangular, and that's pre-selected here. The next option is tear, and the third option is obround. We're going to be looking at the auto relief section in greater depth just a little bit later on. Let's stick with the rectangular method for now. The last option we've got here is to use a gauge table. We can select a table from this list, or we can browse for a table somewhere on our hard drive. When you opt to use a gauge table, the parameters such as thickness, bend radius, and bend allowance are determined by the table's values. However, conveniently, we've got the option to override the parameters in the gauge table if we need to, simply by checking the override boxes. Let's uncheck Use Gauge Table for now, and let's go down to the Bend Allowance control area. We'll use the K-factor method. Accept 0.5 as our value, thickness of 1 millimeter, radius of 2 millimeters, and click OK. Here is our new base flange feature in the Feature Manager tree. I've expanded the branch. To edit this feature, we right-click on it and select Edit Feature. From the Edit Property Manager, we can change the extrusion depth and direction. We can also modify some additional sheet metal parameters such as thickness and bend radius. Let's cancel out of the Property Manager. Another new icon in the Feature Manager tree is the Sheet Metal Placeholder. Let's right-click on it, select Edit Feature. Here we can edit parameters which apply to the entire sheet metal part. For example, we can opt for a default bend radius. Let's cancel out of this Property Manager. Another new icon in the Feature Manager tree is the Flat Pattern feature. Notice this feature is currently suppressed. Let me right-click and unsuppress it. Now we can see how this part looks in its flattened state. Notice that under the Flat Pattern feature, we've got Base Bend 1 and Base Bend 2. I can suppress or unsuppress each individual bend. The sketch that we see under the flat pattern represents the bend lines. We can right-click and suppress that as well. Once we suppress the flat pattern feature, we're back to our folded part. In SolidWorks 2010, we can create multi-body sheet metal parts. Let me create a second sketch. Right-click on the top plane, New Sketch, activate the Rectangle tool, drop my rectangle about here, and exit the sketch. Notice that the first sketch profile I created was an open profile. The second one that I just created now is closed. Let's activate the Base Flange feature. Since we've got a closed contour, we end up with a flat sheet as the shape of the underlying sketch. Let me click OK to accept the default parameters. And let's look in our Feature Manager tree. Notice that the second sheet metal placeholder was added to the Feature Manager, as well as a second flat pattern feature. And this concludes our lesson on the base flange.